Applied statistics. So we're going to begin now to move into the part of the research process that involves analyzing data. And in order to analyze that data, we're going to need to make use of statistical tools. So statistics exist in order for us to make sense of, they say, but it really could be any numerical data. And the idea is that we've got some numerical data. We want to be able to make sense of this data. Statistics is what allows us to do that. And I really like this concept that our author gives us. They also give us a definition of statistics in addition to its purpose. So our author calls statistics the science of collecting, classifying, displaying, analyzing, and interpreting numerical data. So we've got now, this I would say is a little bit broad for a definition. I'm not sure that collecting numerical data necessarily falls in the class of statistics, although we certainly get into that with something like the statistical design of experiments. So there is some science that's involved in even the collection of data, obviously classifying data, what type of data it is. We'll talk about that as we go along. I like this displaying. So this is the work of one of my favorite authors, Edward Tufte. Wrote several books. The most famous, and we'll look at one of these a little bit later, but the most famous is the Visual Display of Quantitative Data, which is a great book as well. So anyways, we've got a number of available definitions here, and I'm sure you've heard other definitions of statistics as a field. As we know, this is a mathematical field. Most of the time you can take a statistics course from a math department, and in this case we're looking at the application of some of those concepts to the data that we have. In this case specifically numerical data, and this interpretation I think is kind of a key element. We want to be able to interpret properly. This is where we do that making sense that we talked about in the beginning. So this is statistics, and of course we're all familiar, I'm sure, with statistics to some degree. We don't necessarily make it into graduate school in the health sciences without having looked at these concepts in some degree. So this is more of a review and a refresher than it is an in-depth look at any of these things. So let's talk about some quantitative research goals. And our goal is to be able to justifiably state two major things. Number one, we want to be able to state causality, meaning that when we are looking at an intervention, for instance, we want to be able to state that the intervention either contributed or was the cause of a change in the dependent variable. Remember, the dependent variable is the thing that we are changing. So, often we've got something like this, x and y, and we're going to change x, so we call this the independent variable, and we're going to observe y, so we're going to call this the dependent variable. And as we change x, we're going to hope to see y improve. Whether improve means up or down is another matter, but that's our goal. So we want to be able to, but just the fact that we see this relationship, this correlation, doesn't necessarily mean that there's a causal relationship. And so that's what we're looking to be able to justify using statistics. We want to justify the causality, either the total causality or the contribution. Now, the other thing we want to be able to state is what we call generalizability. That's the second major point, and that is simply that the findings, i.e. This stuff here, can be generalized to a population. So you've probably heard before that in statistics you've got a population and then you've got a sample. And a sample is some subset of the population. And the population has what are called parameters, and samples are what have statistics. So this is another way that sometimes you see the word statistics used. And we hope that these statistics estimate the parameters of the overall population. So this is some language that sometimes you'll see used, and in this case we're hoping that the statistics that we get generalize. This is the generalization process right here, where the statistics appropriately estimate the parameters. So we want to be able to state with some clarity how confident we are that we have figured out what the parameter is based on our statistics, which are in most cases measures of those parameters of the sample or a subset of the overall population. So this is the generalizability thing, and we want to again be able to justifiably state that we can see cause and that we can generalize the things that we've discovered to the overall population. Just a few more key concepts as we get into our study of applied statistics. The first concept is probability. So probability is something that's distinct from causes. If if you guys are again hopefully familiar with this, but a probability is in most cases a number that can go from 0 to 1. All probabilities are either 0 or 1. If something has a probability of 0, that means that there's no chance that it will possibly happen. And if it has a probability of 1, that means it's guaranteed to happen. And so normally, of course, our probability falls somewhere in the middle, like 7.5. And that just means that there's approximately a 75% chance that this event, whatever it is that we are measuring or looking at, will occur. So we can use that as distinct from causes. So when we talk about probability, in most cases, the measure of probability is not necessarily tied to a specific cause. What we're looking at is just the probability that the event will occur, whether or not that event will occur, what's the probability of that event. So this is where probability comes in. Now, of course, probability can be affected by causes, but when we talk about probability, we're just looking at a number in that case. Another key concept is going to be random sampling. So this is, again, going back to the population. This is our population. We want to make sure that we are getting our sample, that it comes from all over the population, that we're not just getting persons of one type, or I should say items of one type out of this population, but that we are in fact getting a random sample. And there are many techniques for doing this, but for the most part we want to make sure that we get a random sample, and we typically want that sample to also be what's called representative. A random representative sample, meaning that if we know of sort of some variations in this, we want to make sure, let's say that this group here is 30%, and this group here is 30% of the population, and this is 40%. We'd like our sample to have a similar characteristic to that. Now, which members of each group are included in that sample should be random, but we want the sample to be representative as well. That's a related concept to the random sampling. And random sampling is key to ensure the validity of our statistical work. And then finally, we've got uncertainty. Anytime that we assign, for instance, a probability, there's going to be some uncertainty inherent in our measure. Or if we have, remember the concepts of stats and parameters. Well, let's say that our statistic, the parameter that we're looking for, let's say the true value of the parameter is 11. Well, let's say that we get a statistic, and the statistic, maybe it'll be something like 10.5, but there's always going to be some uncertainty associated with that. So 10.5, and then it could be plus or minus, some amount. We know, and we want to be able to quantify whatever this uncertainty is. Maybe the uncertainty is plus or minus, well, if it's 0.5, then we could easily get that, or maybe it's as much as 1.5. So we want to be able to quantify that uncertainty, and we want to be able to control the amount of uncertainty that exists within our thing. So most of the time, we have what's called, let's say our parameter is here, and when we measure our sample, we get something like this. And so, we might say, well, this is the value of our sample, of our statistic, and the true value is over here. And so, there's some uncertainty, and we'll talk about that as we go forward, but, essentially the standard deviation of this normal curve is going to tell us that, the true value of the parameter does in fact fall within the uncertainty that we're measuring in this case. So these are just some key concepts. And again, our goal is to quantify and control uncertainty. We want to know how much uncertainty we have as we go forward. So just a few key concepts and a quick review on applied statistics as a whole, and now we'll move on to look at some other topics in this area.